In this module, we'll talk about degrees, radians, and how to convert back and forth between these two measures that are both ways of describing angle measures. Now, the one that you're probably most comfortable with at this point is degrees, and so we'll start with it. Degree measure would look something like this. If we have our XY axis here, and we have an angle measured off of that XY axis, we want to know the angle measure between the horizontal and the slanted line that we're looking at. That's the degree measure of the angle. So this could possibly be a 50-degree angle measure. If the line was completely vertical, we would have a 90-degree angle, and what that would look like would be this example. This red line, when we look at it, has a 90-degree angle with the horizontal. It is possible to have angle measures all the way up to infinity, but usually what we'll do is we'll reduce the angle measures. Anything larger than 360 degrees is usually reduced back to an angle somewhere between 0 and 360 degrees. Now, radian measure is also used as a way of describing an angle measure, and the conversion between radians and degrees is given by the following equation. 180 degrees is equal to pi radians. So therefore, if we ever want to convert from one measure to another, we would multiply by one of the following two ratios. I would either multiply by 180 degrees divided by pi radians, or I would multiply by pi radians divided by 180 degrees, because both of these are equivalent to 1. For example, if I look at 270 degrees, and I'm interested in converting 270 degrees into radians, I would multiply by pi radians divided by 180 degrees, and with a little bit of label cancellation, we can see that those degree labels would cancel off, and I would be left with a radian measure. Okay, if I take 270 divided by 180, that is 3/2. And so one of the ways the answer could be written is 3/2 times pi, or 1.5 times pi, or a lot of times you'll see it written in this type of a fraction, 3 pi over 2. At this time, you should pause the video and convert 150 degrees into radians. After you've finished working this problem, you should start the video again to see how the solution is obtained. Alright, we're converting 150 degrees into radians, so therefore I want to multiply by pi over 180, and in this case I get 150 divided by 180, which simplifies to 5 pi divided by 6. So this is 5/6 of pi when I'm at 150 degrees. The other conversion that we need to look at is, what if we have a radian measure, such as 11 pi over 6, and want to convert that back to degrees? In this case, we would multiply by 180 degrees over pi radians. In this case, I didn't label it right away, but the radian labels would cancel off, and we would end up with a degree label. 180 divides by 6 30 times, and then 30 times 11 gives me my answer, 330 degrees. So if we're ever talking about an angle measure of 11 pi over 6, we are referring to 330 degrees. At this time, again, you should pause the video and convert the angle measure, 5 pi over 4 in radians, convert that back to degrees, and when you're finished, hit the play button and you'll see the solution. Alright, we're trying to convert 5 pi over 4 into degrees, so we need to multiply by 180 divided by pi. We want the pi's to cancel off. 180 divided by 4 is 45, and then 45 times 5 gives us our final answer of 225 degrees. This concludes the module on degrees, radians, and how to convert back and forth between the two. Although degrees may seem easier to work with right now, visualizing it from a geometric viewpoint, it is important that you are familiar with radians, because as you progress into calculus, a lot of the calculus concepts are easier to work with when we think about them in terms of radians.